Hey everyone, we are going to talk about the central limit theorem. And with the well, hopefully what you've realized is we're going through statistics, and just from your experience with math and other courses, and just any course in which there was some analytical reasoning, I hope you see that our problems are becoming more relevant and more real world as we're getting, let's say, more advanced or deeper into the topic. And this is one in which it's definitely like that. We're getting to more real world applications. What I would like to do is pull up this slide and be able to talk to you about the central limit theorem, being able to actually visualize it in what it does. This is just data of earthquake depths and the frequency in which they occur, given to you as a histogram. So this is just all the data thrown in there. Well, with the central limit theorem, what we can do, and see, if you look at this data is skewed right. There's my tail going out. Okay. And you look at this data right here, and it looks like it's normally distributed. It is the same data, except what we did is that they took a sample size of 50 and they found the means. And what they did was they plotted those means in the histogram. And whenever you do that, your data becomes approximately normal distribution. That is the purpose behind the central limit theorem, that it gets our data to where we can use it. So let's go back here to this. It isn't about going over the central limit theorem, it's about going over some homework problems for you. So just a basic overview: distribution of sample means in correlation to the population mean, sample mean is bar x, can be approximated by a normal distribution whenever n, our sample size, is greater than 30, unless it's already stated there is normal distribution in what we're dealing with. And our formula for our sample means is here. Notice I have sample mean instead, just the individual. And that's all we were looking at before, is just individuals. That x just represents an individual. This represents the sample mean. And with that, we turn around and divide the standard deviation by the square root of my population, or my sample space. So again, individual values, sample means. So here's our problem. The flotation cushion in an aircraft are designed for people weighing between 149 and 191. That's in pounds. The population has normally distributed weights. That right there tells us, hey, we don't need to worry about our sample size. With a mean of 145 and a standard deviation of 28.6. So first thing I'm going to do is we'll get my stuff written up here. So what was my mean? Mean was 145, so 145, and that was the mean. Mean equals 145. And I'll go ahead and write down my standard deviation, and it was 28.6. Because I got to get away from all the words and the busyness. I try to pull everything out and get it to where it's just something simple I'm looking at. Okay, so that's the, let's see, and I'm looking at between 149 and 191. So I'm dealing with a range here. I'm dealing with something like this and this, and I'll write these up here. That's 149 and that's 191. So this is what I'm trying to find, something between here. So if a person is randomly selected, well, one individual, okay, so if a person is randomly selected, find the probability that their mean weight is between, that should be 149, between 149 and 191. So I'm going to end up finding two z-scores. I'm going to end up finding two z-scores for this, and I'm going to use this as my formula. So z equals 149 minus 145 divided by 28.6. So 149 minus 145 divided by 28.6 gives me a z-score of 0.3 or 14, and this is going to be 191 minus 145 divided by 28.6. 191 that gives me a z-score of 1.61. Now I use my table. Let me get my table out. So 0.14, 0.5557, and a z-score of 1.6, so 1.61, 0.9463. And what I'm going to do is I'm going to subtract from the 0.9463 the 0.5557. So 0.9463 minus 0.5557, that gives me the percentage of people, or the area under the curve, the probability of 3906. That means that 39% of the people fall into that. 39% of the people fall into that, or that one person, sorry, that one person, 39 has a probability of 39% of being within that range based off of the mean. So there's that one, and there's a part B to it, and you'll see that they'll give you an individual, and then you got to calculate the individual, and then they're going to give you another number. This one's 32. This is where I'm dealing with my sample mean with my problem. So for this one, I know that I still have the same thing, and yes, see, on this one they've changed the parameters, 140 and 191. So first thing I'm going to do is, whoops, correct that paper for you, is make my normal distribution curve. I have 140, and it was 145, yep, mean was 145 and 191, and I am finding that, except this time everything is still the same. Let me write this down. 145, 28.6, and I'm going to have an x value that's 140, and I have an x value of 191. And I'm using this as my formula. Z equals x bar minus mu over sigma divided by the square root of n. And I'll write that in there too. Whoops, my lid. N equals 32. So there's my information for my formula, what I have. So now I just set it up. Z equals 140 minus 145 over 28.6 divided by the square root of 32. And I'll go ahead and write my other formula, or my other equation. Now I'm going to find those z-scores, and let's do the calculation here. I'm going to have a negative z-score for this one. And make sure you follow your order of operations whenever you enter this stuff into your calculator. Your calculator will not lie to you, so make sure you use parentheses or do it one step at a time and write out your numbers. So I end up with a negative 0.99. And here I end up with, ooh, man. So with this one right here, I already know that one. And once you start using your standard normal tables, that is an exceptionally large uh, value to have, 9.10. I already know that that's going to be almost 100%, but this is how they label it. So I need to look up this z-score, and I'll look up that. So 0.9 and 9, and that gives me 0.1611. So I subtract this from this, and what does it give me? It gives me an answer of 0.8388. That's my probability. That is my probability. 0.8388. Alright guys, that is a central limit theorem problem. Please watch the publisher's videos, critically think and structure your homework, and good luck on your homework.